Alright, so let's get started. So we talked a little bit previously about how we're going to work this problem. So let's start with the reactions. So I'll start with EY. I'll assume that's up. And over here at A is a pin. I'll assume I have AY acting up and AX to the right. So let's find those reactions. So first I'm going to sum moments, and I'll sum moments about A. Remember, that's a good place to start because AX and AY pass through A and create no moment, so I'll get one equation in my unknown EY. So since I'm assuming a right-hand rule for my sign convention, what kind of moment will EY create? Positive or negative?
Positive.
Positive. So I got EY, and its moment arm is 4 feet. And what about the moment created by the 800-pound force about A? Negative. So I'll have 800 pounds, and it'll have an 8-foot moment arm. So it's not hard to see that AY is going to be 1,600 pounds. Okay. Now we can find the remaining reactions. I'll sum forces in the Y direction. Make sure I'm in equilibrium. So I got AY up plus EY acting up, and then this 800-pound force is acting down. So when you plug EY into here, second equation, you have AY is equal to minus 800 pounds. So stop and think for a second. Does that make sense? Does it make sense that AY would be down?
Yes.
And we've used this analogy before about a seesaw, but this is a perfect example. If you think of this structure as a seesaw about E, if I pull down 800 here, you better have an equal weight down on the other side to balance it. So that makes sense. So I like that. I think we're on track with this. So then I'll sum forces in the X direction. I'll assume to the right is positive. And in this problem, all we have is the unknown AX, so it must be 0. Okay, so I'll come over here and put a little breaker. So there's my reactions. Now we can start trying to solve the problem. Now, interesting, you'll notice, since we just saw for the reactions at A, we know AX is 0 and AY is minus 800. Look over here at D, minus 800. So this is very symmetric. So as we work through this, as you find the forces in the elements connecting in A, you ought to see some symmetry in D. So I'm going to work it that way. I'm going to start with D, get some answers, then do A, and you ought to see the same results. And I think you'll also find that as we work through to B, you'll see some symmetry in the results at C. So if you see those kinds of things, you definitely take advantage of them. So again, just because of, I guess a bit of a check is I'm going to start at D first and not use a previous calculation. And then I'm going to go check it and do A and see if they match. And that'll kind of give me some feedback that I'm moving in the right direction. So let's start with the joint at D, which we could have done without the reactions. So here's my joint at D. I have my applied force acting down of 800 pounds. I'm going to assume tension, and I'm going to label that the force from D to E. And I'm going to have tension, and I'm going to label that the force from C to D. And our internal angle here is 60 degrees. So, what should I do first? Some forces in the X or some forces in the Y? Yeah. If you sum forces in the Y, only one of your unknowns has a Y component, so we should be able to solve for that. So let's do that. So I'll sum forces in the Y direction. I'll assume up is positive. So what do I have? I have looks like the sine of 60 times FCD. And that's acting up, and then I have 800 pounds acting down. That shouldn't be too hard to solve for. So what's FCD? 800 divided by sine 60. 923.8. 923.8 pounds, and I got a positive value. So that means it's in tension. Does it make sense that CD is in tension? I think so. When I apply this force here, more than likely this node D is going to move down. And as it moves down, this CD will probably elongate, which means tension. Now that I have that, let's go ahead and sum forces in the x direction, and we should get the force in DE. So I do have the force in DE acting to the left. For me, that's negative. And also acting to the left is the horizontal component of CD, which is the cosine of the angle. So I should be able to solve for DE. It looks like it's going to be negative. Just plug that value in here, and what do you get?
Negative 461.9 pounds.
461.9. Anybody else get that?
Yep.
Cool. Does it make sense that DE would be in compression? I think so. Probably this point's going to move down and probably to the left a little bit. That will make ED get smaller. Shorter means compression. Okay, so far so good. I'll go ahead and put a little squiggly line through those to make sure, okay, I've got that one, I've got that one. 2 down, a bunch more to go. All right, so now let's go over to the mate over here at A. And let's see if we get a similar result. I think you'll see right away when we draw the free body diagram, there's my point at A. When I put AY on there, we know it's acting down 800 pounds. And I'm going to assume tension in force AE and tension in force AB, and the angle between the two is still the same. So you can see these are very similar. They're just a mirror image of each other. So if I follow the same strategy, if I sum forces in the y direction, make sure it's in equilibrium, I'll have the force in AB, just the horizontal component, which is sine 60 of that, acting up, and then 800 pounds acting down. You can see these two equations are identical. So it says the force in AB, if we did our calculation right, should be 923.8 pounds. And all the logic we applied about why this is in tension and compression and all that, I think still applies. And if we finish it by summing forces in the x direction, oops, I got my sum in there. What do we get? Well, we get the force in AE acting to the right, positive, plus the x component of AB, which is cosine of 60. And again, you compare these, they're the same except one's negative, one's positive, but the results are the same. AE is negative 461.9 pounds. Cool. So let's go ahead and put a little mark here and here. So I've got just 3 more to go. Now, where would be a good place to go? Let's examine E. Should I go to E? Well, I can. There's only 2 more unknowns, but notice both of those have x components and y components. So that would be two equations and two unknowns. You have to solve those simultaneously. Or if you slide up to B, what do you see? Again, two unknowns, but only one of them, BE, has a vertical component. So we should be able to get that with the sum forces in the y, and then solve the make sum forces in the x. Now C is going to be the same, just different directions, but I'll take it alphabetically and I'll go to joint B. So I'm going to slide down here to the bottom since I'm running out of room, and I'll do joint B. Since this isn't flowing very logically, I think I'll write 1, 2, 3. Kind of give you some direction where we're going in case you forget. So I'll draw my joint at B, and I'll assume tension in BC. I've already assumed tension in AB. Remember, I assume tension every time, so not surprising. And then also the force in BE. Now all these interior angles are 60, so it just depends on how you want to keep track of it. I'm just going to put my 60 degrees here and here. Any questions about that? So let's just plow away. Remember that I already know AB is something I know. So I'm trying to find BC and BE. So I'll do that first by summing forces in the y direction. Now you can see it gets a little dangerous because I'm going to have to include a previous calculation for AB in my calculations forward. So if I had messed up AB, it's going to just propagate through my solution. That's a disadvantage of method of joints. So looking at the x direction, AB is acting down, so I've got AB, and the vertical component is sine, put AS, is sine 60. And then I have the vertical component at BE also acting down, FBE, and it's also sine 60. Well, this is great. Sine 60s cancel. It just says that FBE is equal to minus FAB, right? And what's AB? 923.8, so that means that this one is negative 923.8 pounds. Okay? So then we can sum forces in the x direction. And we should get BC. So I do have FBC acting to the right. That's positive. Also acting positive is the horizontal component of BE. So there's BE cosine 60. And then to the right, or to the left, I'm sorry, negative AB cosine 60. So I know AB, that becomes a positive quantity. I know BE, where is it?
BE is negative FAB.
Yeah, there it is. It's negative. So, do those cancel out?
They cancel out.
No.
I know.
No. I hope not. No, AB becomes negative, BE becomes negative. So you have to add those two together. So it looks like BC is going to be positive. And see, the cosine of 60 is a half, right? So you should get AB, you should get 923.8. we know AB, right? AB is right here, 923. So that's negative. That becomes positive 923 times cosine of 60. BE is...
No,
BE is... Where did BE go?
BE is
I'm sorry. BE is negative. AB is positive. So they're both negative. And then since cosine of 60 is a half, you'd add them together, you just get 923. Okay. So that gets rid of this one and this one. So we only have one left. So how do we get that? I wouldn't even bother with E. I just go to C because C and B look a lot alike. So I would go to joint C. This would be the fourth step in our process. So let's draw joint C. So acting in tension would be the force BC, which we know. Acting in tension would be the force CE, which is the one we're looking for. And then also acting in tension is the force CD. Now, from previous calculations, we have this one and this one. So I just need to get that. How can I get that with one equation? And maybe the one that uses the least amount of previous information. Yeah, if I sum forces in the y, I only include CD. So let's do that. So we'll sum forces in the y direction. So I'm going to run out of room here, but I'll squeeze it in. They're both negative, so I've got minus CE. I forgot to pencil in that this is 60 degrees, and also this one is 60 degrees. The geometry is very convenient. And that'll be sine 60. And then minus the force in CD, which we're looking for, also sine 60. Which just says that the force in CE is equal to negative the force in CD. And what was CD? Way back up here? 923.8. That seems to pop up a lot. So it looks like our force in CE is negative 23.8. So CE and BE ought to be the same. There's CE and there's BE. They look the same. Okay, cool. So any questions about that? Now, it's taken me 18 minutes to work this problem. What's the likelihood that I would give you this problem on the exam?
Very likely.
Unlikely.
What?
Because it's too much to do. I expect you to do it in 15 minutes, and I usually think that if you can do it in 15 minutes, I should be able to do it in 10 or less. Well, obviously I couldn't do it. It took me 18 minutes to do this problem. Even with me talking and trying to let you catch up, it's still too long. So I think this is a little too much for the exam, not for homework. Okay? So any other questions? All right.